Today we're going to talk about Lesson 3-12, Complex Numbers. Now, what is a complex number? A complex number consists of real numbers and imaginary numbers. Now, this chart can be copied down in your notes, and it's a really good reference for what we're about to go over. Real numbers consist of rational numbers and irrational numbers. Rational numbers consist of integers, such as 1, -5, and 136, and natural numbers. Irrational numbers consist of symbols such as pi and e, which represent real numbers, and radicals, such as radical 2 and radical 5 with an index of 3. Complex numbers equal a real number plus an imaginary number. Now for the important guy. I is equal to radical -1. When using radicals, the number inside the radical, otherwise known as the radicand, can never be negative. In other words, nope, and no. To get rid of a radical, or of a negative inside the radical, use I. So in this example, we're going to use radical -3, and that would become I radical 3. I goes on the outside of the radical. Now here we're going to use radical -5, and you would once again move the negative outside the radical, and it would become I radical 5. Same thing with radical -2 and radical -3. Radical -2 becomes I radical 2, and radical -3 becomes I radical 3. Now we're going to move on to simplifying radicals, using I, of course. Here's a reminder. When simplifying radicals, you have to simplify it down to its prime factorization. So 8 would become 2 and 4. The 4 would simplify down to 2's. And because they're a pair, they move out of the radical, like a couple moves out of the house. And so radical 8 would become 2 radical 2. When using I, do the same thing. Here is the process. We're going to use the example of radical -18. Step 1 is use I to make the radical positive. So radical -18 would become I radical 18. Step 2 would be to simplify I radical 18. So I radical 18 becomes 9 and 2. The 3's move out of the house, and I radical 18 would become 3I radical 2. Now for step 3, we're going to add a plus or minus to the answer, because, for example, 2 times 2 equals 4, and -2 times -2 equals 4. And since we're not solving, just simplifying, both answers would be correct. So you have to make it positive and negative. So 3I radical 2 would become plus or minus 3I radical 2, and your final answer would be plus or minus 3I radical 2. Now you try. Go ahead and pause the video and try radical -50. Now, we're going to radical -50 equals I radical 50. I radical 50 simplifies down to 5I radical 2. And your final answer should have been plus or minus 5I radical 2. Now we're going to move on to perfect squares. Here's a reminder. To simplify a perfect square, you take the radical of it and think about what times itself would equal that number. So 4 times 4 equals 16 in this example, and -4 times -4 equals 16. So the final answer would be plus or minus 4, because both would equal positive 16. Now here's the process. It is the same as before, but right now we're going to get a whole number. So we're going to make it positive. So radical -25 would become I radical 25. Step 2 would be to simplify. I radical 25 equals plus or minus 5i, because plus or minus 5 equals 25. And you keep the I because it's going to be negative 25. So your final answer would be plus or minus 5i. Now you try. This example, we're going to use radical negative 49. Go ahead and pause the video and try it yourself. Now you should have gotten radical negative 49 to equal I radical 49. Then I radical 49 splits off into 7 and 7, and your final answer should have been plus or minus 7i. Now we're going to move on to adding complex numbers. All you have to do is drop the parentheses and combine like terms. So, in this example, we're going to use 8 minus 11i plus 8 minus 11i. Now, they're not always going to be the exact same numbers, but in this example, they happen to be. So we're going to drop the parentheses and write it out as 8 minus 11i plus 8 minus 11i. And we're going to combine like terms. So the 8's go together, and the negative 11i's go together. So in all, we'll get 16 minus 22i. That would be your final answer. Now you try. Go ahead and use the example of 6 minus 4i and 6 plus 4i. Now drop the parentheses and combine like terms. So in this, the 4i's actually cancel out, so you're left with 6 and 6, which is perfectly normal. You don't always have to get i's in there if they cancel out. So 6 plus 6 would equal 12, and 12 would be your final answer. Now we're going to move on to subtracting complex numbers. When subtracting complex numbers, we're going to distribute the negative sign and then combine like terms, like before. So 8 minus 11i minus 8 minus 11i would become 8 minus 11i minus 8 plus 11i. See how that changed right there? So we combine like terms, 8 and 8, and then the i's and the i's. So 8 minus 8 would cancel out, negative 11i plus 11i would cancel out, and so your final answer for this one would actually be 0. Now you try. Go ahead and pause the video and try for yourself 10 minus 8i minus 3i plus minus 3 plus 2i. You should remember to drop the parentheses, so it becomes 10 minus 8i minus 3 plus minus 2i. Combine like terms, so the 10 and the 3, 10 and negative 3, negative 8i and negative 2i, which becomes 7 minus 10i is your final answer. Now we're going to go on to multiplying complex numbers. Foil, and then combine like terms. So, reminder, to foil, you would multiply 2 times 2 to get 4, 2 times 3x to get 6x, then 3x times 2, which would also be 6x, then 3x times 3x would be 9x squared. For your final answer after you combine like terms to be a trinomial of 4 plus 12x plus 9x squared. Now here is a very important reminder. I equals negative 1. So I squared equals negative 1. So we're going to go with 6 minus 4i times 6 minus 4i. So 6 and 6 equal 36. 6 minus 4 times negative 4i would be negative 24i. Negative 4i times 6 would be negative 24i. And negative 4i times negative 4i would be 16i squared. Now, you see that I squared? We're we're going to circle it and come back to it in a second. So 36 minus 24i minus 24i. Now remember how I squared equaled negative 1? Well, it's going to become negative 1 right there. So right now we're going to have 36 minus 24i minus 24i plus 16 times negative 1, because I squared becomes negative 1. So we're going to have 36 minus 48i minus 16. We're going to combine like terms, and your final answer would be, or not your final answer, but we're going to get 36 minus 48i minus 16 for a final answer of 20 minus 48i. Now you don't have to put the negative 48i at the end, but it just looks better. Now you try. Go ahead and use the example of 8 plus 11i times 3 minus 2i. Now you should FOIL, get 24 minus 16i plus 33i minus 22i, I squared. And then that should become a negative 1, and you should have gotten 48 plus 17i as your final answer. Now we're going to move on to solving equations. To solve equations, just solve for x. So in this equation, we're going to use 2x squared plus 32 equals 0. So we're going to subtract 32 from both sides. So you get 2x squared equals negative 32. Now you're going to divide by 2. You get x squared equals radical negative 16. Because to get rid of the square, you would square root. And that's how you'd get rid of the radical negative 16. And so, remember, you can't have a negative inside the radical. So it moves out to become plus or minus 4i. And x would equal plus or minus 4i. So now we're going to go with x squared plus 25 equals 0. So subtract 25 from both sides. X squared equals negative 25. Get rid of the square to get radical x equals radical negative 25, and x would equal plus or minus 5i. Now you try. So go ahead and pause the video and try 3x squared plus 147 equals 0. Now 3x squared plus 147 equals 0. You subtract 147 to get 3x squared equals negative 147. Divide by 3. X squared equals negative 49. You get rid of the square by square rooting, and x should have equaled plus or minus 7. Congratulations! Now you know how to add, subtract, multiply, solve equations, simplify negative radicals, and perfect squares, all with complex numbers. Thank you, and I'll see you guys next time.